Hello, geometry students. As we begin Chapter 8, we're going to need to review some of our algebra concepts before we begin the chapter. We're going to focus on solving quadratics, which are equations that have a variable squared, and we're going to solve that using factoring and the quadratic formula. I've written skip on number 1. Let's take a look at number 2 because it looks a lot more complicated. First off, in number 2, I'm going to need to multiply these two binomials. There's two terms in the parentheses, two terms in this parentheses. Those are called binomials. I'm going to use the acronym FOIL. So I'm going to take my first, that would be 3y squared. 3y times y is 3y squared. O is for outer, which will be 9y. I is for inner, which is 2y. And L is for last, which is plus 6. And that's going to equal y plus 14. I'm going to get my like terms together. So my next line is going to read 3y squared plus 11y plus 6 equals y plus 14. All right, now I need to, in order to solve a quadratic equation, I need to set it equal to 0. So I'm going to move my y. That's going to give me 3y squared plus 10y. I'm going to move my 14. 6 minus 14 is negative 8 equals 0. Now at this point, people, you know you have to factor it. This is called a quadratic equation because it has a y squared. That's the quadratic term. 10y is called the linear term and minus 8 is called the constant. So right now I'm trying to factor it. I'm going to use the reverse of FOIL. So my firsts actually come from my first term, which is 3y squared. So I'm going to need a 3y and a y to get my first terms. My minus 8 comes from my last multiplied. So I'm looking at that and I'm saying, okay, I'm going to need a 1 and 8, or I'm going to need a 2 and a 4. I really don't want to write 8 right here because when I do, I want my outer and my inner to be 10. So I need, this is my outer and this is my inner, and they need to come up with 10. If I write 8 here, I'm going to get 3 times 8, which is going to get me 24. I need 10. So I'm thinking I'm going to work with these two. All right, so at this point, I'm thinking I'm going to write a 2 here. And I'm going to write 4 there, and you're thinking, okay, this is 3 times 2, which is 6y, and that's 4y. Need positive, so these would have to both be positive. Look at that, people. That's not going to get me my negative 8, so that's not correct. This is going to be positive 6y. That's going to be positive 4y, which would get you 10y. But then I need negative 8 when I multiply my last, and that's not correct. So I need to get rid of those. I'm undoing. So I'm going to switch them around. I'm going to make this be 2. I'm going to make this be a 4. I need a minus 8, and when I get outer and inner, I need positive 10. Oops, I wrote them in the same spot, didn't I? Undo. So I want to have 4 here and 2 there. If you look at your outer, you're going to get a 12y And when you look at your inner, this is going to get you a 2y. I'm looking at, I need positive 10, so I'm going to need a negative 2y. That's why this is going to be a negative. That's going to be a positive. Now go ahead and solve. 3y minus 2 is 0. That y is 2/3. And then this one over here, y plus 4 equals 0. Y is going to be negative 4. In our next problem, number 3, we're given another quadratic equation. So the first thing I'm going to do is set it equal to 0. Okay, so now I'm looking for numbers that multiply to get me 32. 1 and 32, 2 and 16, and I'm thinking of 4 and 8. None of those are going to get me 13. So that means I'm not going to be able to factor it. I'm going to have to use the quadratic formula. Maybe when you turn to this slide here, you're going, you knew what that was. That's going to help me solve this. My a is the term in front of the quadratic term, so my a is 1. My b is the term in front of the linear x, so it's negative 13. And my c is negative 32, which is the constant. All right, so I'm plugging them in there now at this point. I'm going to take the opposite of b, which will be positive 13, plus or minus square root. I need b squared, so negative 13 times negative 13 is 169, minus 4, a is 1, and c is negative 32. And then that's all over 2 times 1. All right, now I have 13 plus or minus. I have 169. I'm taking my negative 4, my minus 4, and my minus 32, and my 1. That's getting me a positive 128. All over 2. So now I have 13 plus or minus root, add those two together, gets me 297 over 2. I'm going to sneak up here. Now I'm going to have two answers. I'm going to take 13 plus root 297 over 2. So take your calculator, take 13 plus the root of 297, hit equals, and then divide by 2. So that gets me x equals 15.1. Then you have the minus part. So now you have 13 minus root 297 divided by 2. And same thing, take 13 minus root 297, hit equals, divided by 2, and that other answer is a negative 2.1. Okay, that takes care of covering the quadratics. Now we're going to focus on radicals. We're going to have to be able to simplify radicals in Chapter 8. So I'm going to teach you how to do it in two ways. I'm going to do it with perfect squares. Perfect squares are like 25, 16, 9, 4. So I'm looking for perfect squares that go into the radical, into the root. So 25 goes into 75. I'm using root, and that's 25 times 3. You break that radical into 2, square root of 25. square root of 3. Square root of 25 is 5 root 3. So I just solved that one using the perfect square method. Another method to use is the prime factorization method. And so I'm going to write the prime factorization of 12, which would be making a factor tree. 12 is 4 times 3, and 4 is 2 times 2. Okay, so now underneath the root I have 2 times 2 times 3. 32 is 8 times 4. You're going to be saying, I like the square root method better. The perfect square method. 8 is 4 times 2. Break that 4 down. 2 times 2. Break this 4 down. 2 times 2. Underneath that root, you've got 2 times 2 times 2 times 2 times 2. And then you need to group them in twos because this is really the square root of 4, which is a 2. This is the square root of 4, which is another 2. This is a square root of 4, which is another 2. The 3 and the 2 are underneath the radicals, so write them underneath the radicals, which would be 6. So that final answer is 2 times 2 times 2, which is 8 root 6. So I use perfect squares on number 1. I use prime factorization on number 2. All right, I'm going to move on. I'm not going to be able to do number 3. I'm going to look at number 4. I'm going to break this into 2. Root 2 stays root 2. I'm going to break root 6 into root 2 and root 6. Root 2's cancel. That's 1 root 6. Now having a radical on the bottom is improper mathematics, so I'm going to multiply the top and the bottom by root 6. That leaves me with root 6 on the top, and square root of 6 times square root of 6 is square root of 36, which is 6. My last problem. First thing I need to do is simplify 8. Well, 8 is 4 times 2. So the square root of 4 is 2 root 2. On the bottom I have 2 plus root 3. No, I'm sure you're saying, I need to multiply by root 3. These are together and they need to stay together. You can't just multiply by root 3. You're going to multiply by what's called the conjugate. Notice how I just changed the sign there? Now go ahead and use your FOIL. I have 2 root 2 times 2 minus root 3. I'm doing FOIL on the bottom. First is 2 times 2, which is 4. Outer is 2 root 3. Inner, this is inner, that's positive 2 root 3. Last is a minus root 9. Now some of you guys are writing down 3, and I agree 100% with you on that. Now see this here? This is going to get rid of those radicals. That's what I wanted to do. So on the bottom I have 4 minus 3. On top I still have my 2 root 2 times 2 minus root 3. 1 on the bottom. I'm going to move sideways here. I got 1 on the bottom. I'm distributing on the top. 2 times 2 is 4 root 2. Second term is minus 2. You've got a root 2 and a root 3, which gets you a root 6. So we've just reviewed our algebra.